Welcome to the course of wireless sensor networks. This is lecture number 14, and today we will be talking about data-centric routing in wireless sensor networks. I am your instructor Zeeshan Bangash. So let's move to the agenda of our today's discussion. Wireless sensor network comprise of small nodes that have sensing, computation, and wireless communication abilities. Many routing, power management, and data dissemination protocols have been specifically designed for WSNs, where energy awareness is kept as an essential design issue. However, the focus has been given to the routing protocols, which might differ depending on the application and the network architecture that has been designed. In our today's outline, we will be discussing introduction about some routing mechanism. Then we will be talking about the routing models, and uh, at the end we will talk about some data aggregation models for wireless sensor network. So let's move to the first uh, agenda item, that's about the introduction about the data centric routing in WSNs. The emerging field of WSN combines the computation, the communication, the sensing into a very tiny device. We call it a node. By the use of advanced network protocols like networking protocols, these small nodes form a sea of connectivity that can extend the reach of that physical world. WSNs basically refers to a group of spatially dispersed sensors that are used for recording the physical phenomena or monitoring any phenomena in the environment. They are also responsible for organizing the collected data at a central location. We call it as a sink. Wireless sensor networks basically measures environmental conditions like sound, like pollution levels, like temperature, like wind speed, and it consists of 1,000 of sensor nodes that are basically directed to observe any phenomena, to collect data, and then report it to a specific point. We mostly refer to it as a sync node. The sensor nodes equipment includes, as already discussed in the previous lecture, it comprises of radio transceivers with an antenna, a microcontroller, an interface electronic circuit, and an energy source, usually a battery. So there are some properties we have already discussed in our introductory part about a sensor network, and particularly some specific properties related to the sensors. That includes the reverse multicast phenomena. And similarly, since the data is collected at multiple locations, as there are thousands of sensors that are deployed to collect data for a phenomena, and we can receive multiple data from a common location, so there always a possibility of data redundancy. And then there is some mechanisms that in as per the design of that network, some sensors may not be mobile. So how to uh, collect an accurate data for a phenomena or for a particular location? So that are some of the sensor net properties that have to be kept consideration. And then the most important feature is the data aggregation mechanisms, in which we try to eliminate the redundancy of the data at multiple positions or at multiple sensors, and we try to aggregate the data and store the aggregated form of the data at a particular location or at a particular cluster health level. So that helps in reducing the redundancy of data. And similarly, since every sensors have a very limited energy storage constraint, so it is also helpful in that case in addressing the limited resource constraint challenge for wireless sensor network. So data aggregation is helpful firstly in eliminating the redundancy of the data, and the second important thing is that because of this aggregation mechanism, so the transmission, which consumes the most power in a wireless sensor network, and we already know that the sensors are very limited in their power, so we can reduce the power consumption using the data aggregation, and that's because the data aggregation helps in minimizing the transmission. So these are some of the data centric routing in WSN, some properties that needs to be considered while communicating in a wireless sensor network. And why we do data aggregation? So the main priority is basically to save energy, because we are very limited in energy in WSNs, and we want the networks of wireless sensor networks to be live for a long time. So in order to consume the energy in a very limited way, so data aggregation mechanisms needs to be incorporated for wireless sensor networks. Now let's talk about some of the routing models for wireless sensor networks. As we know that the uh, routing in a sensor network is very challenging because of some of the characteristics that distinguish this specific type of network from wireless ad hoc networks. That includes the number of sensor networks can be several orders of magnitude higher than the ad hoc networks. So these characteristics, because of the bulk deployment, make it a distinguished type of network than the wireless ad hoc networks. So as the sensor networks are very densely deployed, as well as they are mostly prone to failure, so the topology of the sensor networks that changes frequently, and it uses the broadcast communication. However, in ad hoc wireless networks, they use normally the point to point communication. So this is the main difference when we consider the communication pattern of a wireless sensor network in comparison to the ad hoc wireless network. Sensor networks are mostly very limited in power computation capabilities. We already discussed this, and they are also very limited in memory, and they do not have a global identifier because of the large overhead and large number of sensors that are deployed. So these are some of the constraints that make this type of network distinguish from wireless ad hoc networks. So let's talk about some of the routing models for wireless sensor network. So there are two routing models, and the first routing model is basically the address centric model, and the second one is basically the data centric. It's basically the way the communication in that network took place, or the communication that took place in wireless sensor network. So what happened in address network centric routing model, that each source basically sends data independently to the sink. So there is no intermediate node involved in its path that routes the data to a particular destination. So every source independently tries and sends the data to the sink. So it can be shown in the figure that the source 1 wants to send data to the sink, so it will send that data independently through node A. Similarly, source 2 wants to send data to the sink, so it will process that data and select a particular path, and then through that node B it transmits that data to the sink. However, in case of data-centric routing models, routing nodes are in route that basically looks and process the data that is to be sent to the destination. So just look at the figure that when the node 1 wants to send data, so it just forward the data to a particularly in routing node, that's basically the B, and then this B forward this data to the sink. Similarly, when the source 2 wants to send that data, so it sends that data to the routing node, which is basically the B, and then this B look at the different paths, and then it sends that data to the sinks. So this is basically the difference between the two routing models. Now, there are some scenarios for routing model, and in the first scenario, all the sources in the sensor networks have different type of information, and they are observing some different phenomena. So there's another scenario that the sources are observing a specific phenomena at a particular location, and they might have the same data. And the third scenario is that the source sends information with non-deterministic redundancy. So this is another scenario. So these are some of these scenarios for a routing model that needs to be considered. So whenever we look into any communication model in a wireless sensor network, so there might be any of the scenarios which have been shown on the slide, that whether all the sources or all the nodes are observing same phenomena and sending that same information, or they may be sending some different information based on the location of that sensor, and similarly, or they may be sending information with a non-deterministic redundancy. So we have to categorize or classify the scenario while looking at the design of a wireless sensor network. So let's discuss about some of the data aggregation models in details. So first of all, the data aggregation, and particularly the aggregation function, is very simple. So what it happens that it try to suppress the duplication and perform some aggregation function, and the duplication of the data can be avoided. So the data received from multiple location is passed to an aggregation function, and then a value is calculated based on the data received from different location, and then that aggregated value is passed on to a central location or to a certain level. So it suppress the duplication. So for example, we can store, instead of the sequence of data, we can store the maximum value or the minimum value, or may store it in a certain compressed form, in an aggregated form. For example, node transmit one packet for multiple inputs. So instead of storing that data at a different location, so we can aggregate it. So there is another aggregation mechanism which we called an optimal aggregation, and that follows a multicast tree mechanism. We call it a minimum standard tree problem. And what happened in this minimum standard tree problem, which is an optimal aggregation, that the optimal number of transmission is equal to the number of edges in that minimum standard tree. So we will, in the upcoming slide, we will look at the tree, and we will understand what this optimal aggregation is. So there are other optimal aggregation that that it is an NP hard problem. Just look at the data aggregation Steiner tree. So what happened in this Steiner tree, that there is a weight tree, and there a minimum weight tree connecting a designated set of vertices, which we call it terminals, in a weight graph or point in a space. And this tree, which is known as a minimum weight tree, it includes some non-terminals, which we call it Steiner vertices or Steiner points. So just look at the diagram shown, in which there are some non-vertices, or we can call it a Steiner vertices, like A, B, or G, and they are basically the non-terminals. Now there is another mechanism which we called a suboptimal aggregation. What happened in this suboptimal aggregation, that we propose a point which we called a CNS as a center at a nearest source, in which all the data aggregation processes performed. Then there is another suboptimal aggregation, we called in an SPT, or the shortest path tree. So whatever is the shortest path, so the data aggregation or the suboptimal aggregation is performed at, and then there is another data aggregation or a suboptimal aggregation technique, which we called a git or grid incremental tree. So you can choose any of the suboptimal aggregation based on the design, whether you are following the shortest path, or you want to create a center near to the source, or you are following the JIT. So what are the performance measures, that whatever suboptimal aggregation techniques for data aggregation you use, you have to calculate the energy saving and the delay. So whether the technique is consuming or saving energy for your wireless sensor network. So this is one of the performance metric you have to measure when you are implementing any suboptimal aggregation. And the second most important thing is the measurement of the delay, that how much delay in the transmission will occur if you follow any of the suboptimal aggregation technique, whether it's an SPT or a CNS or a GIT. So that performance metric needs to be considered in a data aggregation when you are considering the data centric routing in WSNs, and that can be the performance measures that includes the energy consumption measurement or the delay measurement. And the third thing is the most important thing is in case of a WSNs, in which we know that there are thousands of deployment, is that you measure the robustness of the technique or this aggregation technique. So you can select, you can give priority either to an energy saving or a delay and or a robustness, and based on that you select any one of the data aggregation technique. Now there are some source placement models. In one of the model is that nodes are distributed randomly in an area at a per unit square, and they are transmitted in some communication radius. And the second is that you perform an event radius model, which is called an event radius model, that single point of origin of the events from a particular point, and then the data source in sensing the range S. And the third thing is the random source model, where the nodes or the k nodes are randomly distributed as sources. And another thing is the source placement event radius. So you can just look at some of the simulation that have been taken from the reference book, in which you can just look at the event radius shown by S in that simulation, which is a source placement mechanism. Similarly, the simulation for the event radius source placement. So you can just look at the radius from the source shown, where k is equal to the 10 sources shown in the simulation. So you can consider this event radius mechanism in terms of the source placement. So in our today's discussion, we talked about the wireless sensor networks. We talked about some routing models. We talked some of the techniques related to the data aggregations models, and this is the reference book from which the content have been taken, and you can just consult it. And thank you very much for patiently listening. Take care. Allah Hafiz.